So we want to evaluate this integral. B is greater than 0, and therefore we have a simple pole on the real axis. The x to the a indicates that we're going to have a branch cut somewhere, and it's easiest if we make the branch cut along the real axis. So we'll end up with a branch cut with a pole in the middle somewhere. So our contour, okay, will look something like this. This is B. And our contour would look something like this. We do a nice circular contour, radius r. As usual, this is distance epsilon, and we consider label our contour gamma, and we consider this integral with z instead of x. So the integral along here is just I, the integral we want. As usual, we just check the other things give you 0. So we've got okay, so this r cancels this r, and we've got r to the minus a. A is positive, so this therefore goes to 0, and we need this integral along here. So from infinity to 0 dx, here z is x times e to the 2 pi I, so we end up with x to the a times e to the 2 pi I a, and x minus b. And then just the integral around here. Same with this. So this will end up being of order, we just got b here, so we end up with epsilon to the power 1 minus a. So a is between 0 and 1, so this quantity here is between 0 and 1 as well, so we're fine. This will always tend to 0. So what we're left with is these two integrals. So swap the limits and get a minus sign. We end up with 1 minus, and then it's e to the minus 2 pi ia times I. And that, the only pole we have is at x equals b. So, sorry, I forgot to indent this, of course. This needs to be an indent around the pole, both sides. Okay, so we need to evaluate the residue of this on this side and on this side. So the answer up there, that's got to be equal to pi I, because they're half a pole. And then we've got the residue of this function at b and the same function, and I write it at b times e to the I 2 pi. So here we just get a residue of b to the a, or 1 over b to the a. But when we do the same thing here, we'll end up with b to the a, but also multiplied by, on the bottom, e to the I 2 pi a. Okay, so I can take out a factor of b to the a, got 1 plus, and I'll just write it as e to the minus I 2 pi a. So rearranging then gives me I equals pi I e a. Then if I multiply top and bottom by e to the I pi a, so on the top this will give me e to the I pi a plus e to the minus I pi a, and on the bottom I'll get, dividing by this, I'll get e to the I pi a minus e to the I pi a. So if I put factors of 2 here and a factor of 2 here, we sort of recognise this is cos pi a and this is sine pi a. So we end up with the final answer of cos over sine, which is cot pi a. So this is equal to pi over b to the power a times cot of pi a is the final answer.